Welcome back. Off we go. Now, shape. What is shape dictated by? Shape is dictated by the primary sequence of amino acids. AA, amino acids, which are used to make proteins. Amino acids, short form. So I don't have amino acids anywhere, do I? Oh, wonderful. Primary sequence is just what amino acids on the left, what's the second one, what's the third one, what's the fourth one, the order of the amino acids. And that is dictated by proteins assembling these amino acids as they're made. Then you have forces that cause this primary structure to fold in on itself. And a large part of that is hydrogen bonding. Anion cation attractions. Ionic attractions or bonding if it's an ionic bond. London forces for non-polar amino acid groups. So we call those hydrophobic interactions. Do you know where the amino acids go that are non-polar? Such as those with aromatic rings, or those with carbon groups here that are not polar, like a sec-butyl here or an isobutyl. What happens with those is the protein folds itself so those stay away from the water, which is generally outside the protein, and they curl around to the inside so they can be around each other because they're not attracted to the water, they're attracted to each other. So we call that hydrophobic interactions. London forces. Disulfide bonds are very important. And disulfide bonds are RSH from cysteine. That's the only amino acid that has a thiol. And it goes to RSSR with another cysteine. So now you have a covalent bond between two sulfurs. And that there is just a very badly drawn sulfur. Disulfide bond. And yeah, they cause proteins to fold over. Fairly rigid interaction there causes the structure to change drastically. And if you want a little discussion of that, go to the portion of Organic Chem 1 where I talk about the curling of your hair. That's largely disulfide bridges causing that phenomenon. And when you're asked to draw little proteins, you won't be starting with these guys. These are the unicorn amino acid versions of them where there's an actual amine and an acid. That's not real. You'll be drawing from the form on the handout, of course. Use the handout, and that has the proper ammonium carboxylates all the way across. And I copy pasted from the first page where the starboard stuff was, but I think we can get through it. So what do? Well, you have to remember that all biological molecules that are large, the vast majority of them are made by condensation reactions. And we have to look for our short forms. The handout, I use the one-letter short forms here. K, W, tryptophan, G, glycine, and R, arginine. And when they're listed this way, we have what's called the amino terminal on the left. This is understood. We always do it this way. It's the convention. And that means there'll be a free ammonium out there. And this will be the carboxyl terminal. It'll have a free carboxyl group. I will highlight those as well, because when you're done, you'll see exactly what you have in the originals. The amino terminal will be this. The carboxyl terminal will be this. Okay, my pen just stopped. There. So when you're done, you better see this green piece as is and this blue piece as is. And let's get going. Please go to stick figures. We're well past where you have to ever draw CH or CH2. So we got NH3 plus connected to C, connected to carbonyl. And there's the R group is a CH2 4 times. 1, 2, 3, 4, and then an NH3 plus. It's got an ammonium side chain. And you'll notice the pKa's are listed for the side chains, aren't they? That's a big part of this chapter. NH, you condensed those two amino acids. Where did the water come from? The O for water came from here. The two H's came from here. You're left with one H, and it's attached to the carbonyl right there. Water's what I took away. And we're going to a CH, C-double-O. This goes to CH2, goes to an aromatic ring. It's called an indole ring. We didn't talk about it. Most semesters I do talk about it. Time is short during these trying times. Indole ring on tryptophan. And that takes us up to its carbonyl, which is condensed with the next nitrogen. Carbonyl to NH to carbonyl. Now it's a repeating pattern here, huh? NH, carbon, carbonyl. NH, carbon, carbonyl. NH, carbon, carbonyl. NH, carbon, carbonyl. And now glycine is boring. It has no group there. It's a CH2. Just leave it. And then arginine has its own NH. And a little more room over here. Comes up to a carbon that has CH2 once, twice, 3 times, NH. Hey, this looks familiar. It's got the guanidine. Oops, NH2 plus. It's got the guanidinium residue, doesn't it? Arginine, there's where the G is. And CHNH and free carboxyl. Oh, I should have drawn it in baby blue. I can do that in baby blue. So you see your amino terminal here. And you see your carboxyl terminal over here. And congratulations, you drew a tetrapeptide. Is it a protein? No, it's a little too small to be called a protein, but you know, it's on its way. It's a baby protein. Here's how you name how big proteins are. Dipeptides are 2 amino acids. Tripeptides are 3. Tetra. And once you get past, some people argue if you have 4, you're in the oligopeptide category, which is a bit of a range, somewhere between 5, 12. Some people between 4 and 11. Oh, sorry. 4 and 11 is the number of peptides. I'm not reading my own notes right. Peptides. What the heck is that? Your biology teachers forgot peptides are really amides. Yeah, when you linked up two amino acids, you made one peptide bond to hold them together and lost one water. When you did three, like this example up here, you only lost water here and then again here. So it's always losing one less water than the number of amino acids. That's been known to show up on things like PCATs, MCATs, and DATs. So if you have a protein with 421 amino acids, how many waters were released? 420 upon synthesis of the protein. And I think that's all that needs to be said there. Protein structure, as you know, the primary structure is a very large part of how the protein is going to have its shape. So we have developed over the last 150, 200 years methods of determining protein structure. So what I did was I went to a database and found a primary structure of hemoglobin B subunit. I just found a 60 amino acid sequence of it. And what you have to do is put some marks on this thing. I'm not sure I'm going to ask you to do it on your test because I really don't think I want you to copy out this whole long thing here. So I don't know. It's a nice, easy question. So you do want me to find a way to put it on your test. Right now, it's not easy. You have no idea what these things mean. What all these things do is they'll cut this into pieces. And we need to know what each of these chemicals does. So cyanogen bromide cuts the C terminal of a methionine residue. And yeah, you're going to learn the mechanism for that too. So which one is methionine? Well, we got to go to page 1, don't we? Methionine. You'd think it would be an M. It doesn't have to be. M is methionine. So, and we're going to look for all the M's and put a cut on the right side with the right symbols that were asked for in the question. So methionine, we're going to use a squiggle on the right side of every M. Do we have any M's? We have one here. And any others? Not seeing them. So that's all it would do. Cyanogen bromide would take this thing and cut it right there on the C terminal, which is the right side. Remember that. The right side is the C terminal side. The left side is the amino terminal. Trypsin is a digestive protein. Trypsin. We'll just went in blue. Trypsin cuts C terminal of RNH3 plus side chain amino acids. What? Trying to help you remember which ones. So if you can remember that, you can go find them. So side chains are the chains sticking off the bottom of all of these. It's one where there's variation. Methyl side chain, CH2, CH2, CH2. Here's an NH2 plus. That's not qualifying. There's two with NH3 plus. There's lysine. And well, I take it back. NH plus of NH3 plus or NH2 plus both work. Lys and Arg. Just have to help you out here. N plus side chain. that simplifies your life. N plus side chain. Doesn't matter if it's NH2 or NH3. So that's lice and arg. We need the short forms. Lice and arg from page 1. Where are you, lice and arg? Arg, R. And lice, you'd think L, right? No, it's K. L was taken already by leucine. So arg is R because A was taken by alanine. R and K. Remember that. R and K. So we're going to put what kind of mark? Trypsin double line, R and K right side. K and if I miss some, this is where you're going to pipe up for me. R and K. There's K. R and K. There's a good chance I'll miss some. R and K. Make sure I didn't miss any. Do you think I got them all? If I have an R or a K there without the double line, then I missed one. Chymotrypsin. Let's see. I need that area to work on that problem. And we'll do chymotrypsin in green. Oof. Chymotrypsin cuts, and it's always C terminal, so that makes your life easier. Of benzene containing amino acids. So if I said aromatics, that would lead you to believe that histidine would work too, and it doesn't. So just look straight up for the 3 benzenes on the page. I see them. Phenylalanine. Oh, try to remember that this is a phonetic one. F. Phenylalanine. F. Tryptophan. W. Oof. Tryptophan W. And tyrosine. Y. None of them has their first letter. Phenylalanine, tryptophan, tyrosine. You don't have to memorize those letters, right? Phenylalanine, tryptophan, and tyrosine, R. And tidy up my notes here, make them nicer for you. And consistent. Lice was a K. Arg. Wait. Arg was the R. Tyrosine was the Y, wasn't it? Caught myself. Somebody else was about to catch me too. Okay. So chymotrypsin, we're looking for FWY. FWY, and we're going to use a big green X. FWY, FWY. FWY, F. WY, W. F. WY, F. Just keep saying it to myself. I might not miss them. I think I got it all. FWY. And our last one is the easy one. Phenyl isothiocyanate. Wow. Phenyl isothiocyanate. And I'm just going to put that upstairs. It's the easy one. purple. Phenyl isothiocyanate. C-terminal of amino terminal. What? C-terminal of amino terminal residue. And yeah, that word residue, protein people use it all the time. In this problem, we have 60 residues. There's 60 letters here. The first residue was an E here. The amino terminal is there. And you're going to use just a normal old single cut right there. So that's the easy one. You do that one first on this question. You put a line on the first one, and that's it. Okay. So that's interesting. That's an introduction to what these things do to break our proteins down to simpler units. Now, if I carefully design a problem, I can use a smaller amino acid protein and have a problem that's solvable just with that information. And hopefully this is one of them. So you'll see a couple of these on your test, maybe just one. I'll just do the one in the short answer. I did steal this one from the multiple choice. I assume you're going to find a nice one from the short answer from one of the old exams, and we should do that on review day. But we'll start with this one here. It says we have an octapeptide, and the amino acids are listed alphabetically down here. What this means is there's 2 arginines in the octapeptide. So 2, 3, 4, 5, 6, 7, 8. And Edmond is nice because it tells us the first one is cis. So Edmond up there was purple, so let's put in purple. So right away, I know cis. Straight there. Now, what chymotrypsin does, which is interesting, because it looks like the chymotrypsin information is the same as this information. Chymotrypsin does what? It cuts the C-terminal of benzene-containing amino acids Ph, terp, or tier. Does my molecule have Ph, terp, or tier? Answer, yeah. And chymotrypsin green. So the question now is, if nothing got cut, which is basically what this says, doesn't that mean there couldn't be anything after tier, or else I would have got a second fragment? Yeah. So this is good news. There can't be anything after tier if you do a chymotrypsin experiment and tier ends up with all of the other original amino acids. That means tier is here. It's at the end. C-terminal. Can't have anything after it. Now remember, trypsin, C-terminal of the N plus is either lysine, lyse, or arg. And here's how I do that for you, or for me, for you, for everybody. Lyse has to be after Lu because Lu stayed with it. Arg has to be after these two. Arg by itself, only 2 ways to do that is arg, or arg tier. That's the only 2 ways to have arginine by itself. You're going to get cut. You're going to get cut there and there. Oops, tier arg. Sorry. My mistake. To get arg by itself. Arg or tier arg. Because it's going to cut there and here if there were things after arg. because that's what trypsin does, or cut here and there. That puts this arch by itself. This arch or this arch. And we'll figure out which one's ours. I kind of know already that it has to be arch because I can't have our, let's see, tears at the end here. Yeah, tears at the end. It can't be before arch. It's at the end. That's what this says. So, but tear must be after arch in this problem. Tear after everything, which means after arch too. So just put a gentle X through the bottom option. Okay. So I know I have arch. We're closer to done than you think. I know I have arch. Edmond degradation, cis first, chymotrypsin, tear at the end. What does this mean? Well, we already know tears at the end. I don't see lyse or arg in this fragment, which means it's the C terminal. Even if I didn't know this piece of information here, this says this is C terminal. So I can expand my knowledge now. Tear, thir, can't be thir, tear. Sorry, can't be tear, thir, because tear's at the end. And we already knew about cis. Just copy it down here. I think we can finish this problem pretty soon. We have to have arg, and arg has to be after cis seer in this fragment. So right there, I know it's cis seer arg. Cis seer arg. I'll put a pink highlighter on it. And this, combine those two together. Cis seer arg. Or 7 out of 8 amino acids done. This goes in here. The only question is where's the 8th one? Where's the 8th one? What is the 8th one? Well, I got to do some scorekeeping because I lose track of where I am sometimes. Here's where I am. I'm just going to check off. Oh, wait, I know I'm done. Cis, seer, arg go together, and cis is first. This cis is first. I just got to do my scorekeeping and see which one's the only one left over because I only have one more of it out of 8. And I know some of you have done it already and say, Dr. Whitaker, why haven't you seen it already? Yeah, just doing it systematically. I'm going to check off cis. Check off in hot pink. Cis is off my list. Seer. It's S-E-R, not Y-R. Was there S-Y-R typo anywhere? That just happened in my brain. Sir. Next, arg. And then third tier. Mr. Lyse, you're up. And then we're done. Just put it in, I don't know, purple. Lyse. Done. There's other ways to tackle these. It's just problem solving 101, like puzzles. We love puzzles, right? And I think we may be leaving it here unless this is definitely related. We'll come back to that one. Was there a problem underneath this one that I missed? No. It's good.
Professor, I have a question.
Yes. Mm-hmm.
So in this page here, I think you left a Y at the end.
I left a Y on this one here.
Mhm.
A Y. What do you mean a Y?
Well, in the top one, where
Uh,
we did the cuts, there's a
oh,
Y.
I missed a Y. I was supposed to do what with the Y? Oh, geez. It says Y. That's right. Chymotrypsin cuts C terminal of yeah. So my green cut have to go after the Y, and that was X. I missed one. Good job.
And then,
Thank you. Another
and
one?
then for the bottom question,
This
what
one.
about the Leo, the LEU?
I don't have Lou.
Does it go? No.
1, 2, 3, 4, 5, 6, 7. I can't count is another issue I have in life. We're still done, but we had 2 to go, not 1. And yeah, I don't have Lou checked off either. Now, the nice piece here is we're missing both Lou and lice, right? Don't have them checked off, right? And this says lice has to be after Lou. Right there. Fact. Trypsin cuts the C terminal of lice and arg. So that means everything after lice was cut. Everything before lice stays. And that means Lou's before lice. So you put Lou lice to finish this problem. And Lou and lice. I appreciate that so much. Thank you very much. Because that fully completes it. We only had 7 out of our 8 in there. And yeah, we're going to pick up over here with PI. You guys will be doing a lot of the learning on these 2 videos. I spent a lot of time on those last semester. And you can't click them from here. So I would just go to our video list and go to the chapter 27 items. You'll see these titles. I stole this straight from the video list. And watch those videos after we're done today. So we'll see you very soon. And take care.